Today we're going to be talking about translations. So a translation is a figure that can be slid in any direction. So here we have the pre-image, and that every point slides corresponding to another point. This point here slides a certain amount of distance over, and these two arrows are congruent. If you can see I move them around, they're the same length. So it's going to be moving across a certain distance, and it's going to be moving in the x direction and the y direction. So, translation. A translation is a function that maps each point to its image along a vector called the translation vector. Each segment joining a point and its image has the same length as the vector. Segment is also parallel to the vector. So, as we're going from A to A prime, you go across some vector. Well, that vector, like I just talked about, is parallel and the same length. Okay, so the idea behind this, okay, if you have translating a point across some vector AB, all you're doing is adding the x coordinates of the vectors, adding the y coordinates of the vectors to get your new points. Okay, all you're doing is shifting. So like here, we move the pre-image of -2, 3 across 7, 4. So since 7 is positive, I went right 7. Okay, and then 4 is positive, so I went up 4 to get to my new point. So doing an example with this. Okay, I need -3, 2. Okay, so I'm going to shift every point 3 to the left since I'm negative and 2 up. So this point T, I'm going to shift 3 to the left, 1, 2, 3, and then up 2, 1, 2. So that's my T prime, my new value. U shifts 3 to the left, 1, 2, 3, up 2. There's my U prime. V shifts 3 to the left, 1, 2, 3, up 2, 1, 2. And that is V prime. And so we have our new figure. Okay, we have that, and we want to graph penta with those vertices along the vector -5, 1. Okay, so I have the point 1, 0. I have the point 2, 2. I have the point 4, 1. T is for -1. And then A, which is 1, 2. Yeah, 1, 2, -2. So I'm basically taking that pentagon and I'm going to be shifting that 5 to the left and 1 up. So my P prime point, another way you could find it is you could do, let me do it in a different color. P prime is take this 1 minus 5 and 0 minus 1 to get P prime is -4, -1. So 1, 2, 3, 4, -1. And that makes sense because I shifted over 5, down 1. And then we have e prime. So 2 minus 5 over 0 minus 2, that's going to be -3, -2. So -3, 1, 2, 3, -2. I'm sorry, I don't know where I got that 2 from. That should be a 2, so that changes this to a 0. I apologize, I wasn't thinking. I was wondering why that didn't look right. So -3, so if I shift this 5 over, 1, 2, 3, 4, 5, that's -3. Shift it down to, that's my e prime. And then n prime for 1. If I subtract 5, so I do 4 minus 5 and 1 minus 1, I have the point -1, 0. But I want to go, yeah, that's right. Oh, I still messed up this e prime. I don't know what my problem is today. So this should be 2 minus 1, so that should leave me at 1. I should have just counted. Quite honestly, I keep messing this up, so I'm just going to count. 1, 2, 3, 4, 5. And then I go down 1. I go, for the t, I go over 1, 2, 3, 4, 5, down 1. And I keep messing this up because I'm trying to go too fast. A, 1, 2, 3, 4, 5, down 1. So I have my a prime, there's my t prime, and then my n prime in our new value. I apologize for so many mistakes on that. Okay, our next example. So the graph shows repeated translations. In the animation, describe the translation from position 2 to position 3 in function notation and in words. So let's start with words. Okay, so from 2 to 3. So from 2 to 3, I go 1, 2. So I go left 2, and then I go down 1, 2, 3. In function notations, we take our x values, we subtract 2, we go y, we went and we subtracted 3. Now our translation vector from raindrop 3 to raindrop 4 using the position vector, I don't go any in terms of the x's, so 0 for the x's, and I went down 1, 2, 3 for my y's. Okay, so that is your video on translations.